Welcome back, physics folk. I'm super excited today for video 3-1. We are going to be diving into some new content today. We're going to be focusing on vectors in physics, as well as adding and subtracting those vectors. So I will tell you that vectors is a really important part of learning and understanding physics, and it's going to apply some concepts that you probably learned in your geometry class or maybe trigonometry class, depending upon where you are in terms of your math skills. So make sure you have your calculator handy and ready to go. Hopefully by the end of this video, you will be able to understand the horizontal and vertical motions of an object are independent of one another, and explain the concept of vectors and how to relate trigonometric functions to those. You should also know how to add and subtract basic vectors today. So let's talk a little bit by a vector. A vector is a quantity that is specified by both a length and a direction, and the length of this vector is known as its magnitude. So think about walking around in a large city, a large downtown. Think about walking around in a large city in a large downtown metropolitan area. It's really difficult to move to one place or another directly, making a direct straight line in the city. It usually takes us city streets east and west, north and south in order to get to our location. So we may have to go 3 blocks north and 1 block east in order to get to our location. Or we may have to go 5 blocks west and 2 blocks south in order to get to our destination. Now, while that is the distance that we actually go through and cover, it really doesn't focus on the displacement of where you started and where you ended. And so in order to do that, we're going to have to do a little bit of math to figure out where you started and where you ended, and then think about how can we calculate the true displacement of the object. Because remember, distance and displacement are really two different things. So in order to determine the displacement, again, you're going to need to know the components of the vector, the distance walked on the street, and the direction in which you walked, kind of like what we talked about previously. You're going to need to know whether you walked so many meters east and so many meters north in order to determine your exact displacement. You can think of these quantities like they are on the x and y axis. So think triangles. What might we actually use to solve for these vectors? Well, if I know I'm going east and west and north and south, in order to figure out exactly what my displacement is, I can use a variety of trigonometric functions such as sine, cosine, tangent, and even the Pythagorean Theorem in order to be able to determine the displacement of myself. Simply put, basic trigonometry is going to allow us to solve for vectors. Remember, for any sine theta, remember that theta represents an angle, is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So we can mathematically rearrange these equations to tell us some information. R of x, or the distance or displacement of the x-axis, is given to us by taking the distance that we've actually traveled multiplied by cosine of theta. Conversely, we can also get our y displacement by knowing our total displacement times sine of theta. We can also learn the angle at which our displacement occurs by taking the inverse tangent times the displacement on the y-axis divided by the displacement on the x-axis. And then we can use the Pythagorean Theorem, a squared plus b squared equals c squared, to solve for a variety of displacements as well. Now we can utilize and manipulate these formulas in a variety of different ways to help us solve for a variety of variables in various problems. We just need to make sure that we understand what we're looking at and have a really good, strong understanding of geometry and trigonometric shapes as triangles. At a local ski resort, you take a rope to the top of the bunny slope. Your displacement vector for this trip has a length of 190 meters, and your points at the angle of 26 degrees above the horizontal. How far have you gone in the horizontal direction and vertical direction? So let's map this out a little bit. We know that we start down here and we go up in a horizontal direction. We're 26 degrees. And we know that this is 190 meters. The question is asking for what is x and what is y. So it's very straightforward how we can go through and calculate and solve these types of problems. Recall some of the previous formulas that we've looked at. R of x is equal to r cosine theta, and r of y is equal to r sine of theta. We know our angle, so we know theta. Theta is 26 degrees. We know our value for r, which is 190 meters. So now we can go in, plug in, and solve to determine the distance in the horizontal direction and the distance in the vertical direction. So r of x equals 190 cosine of 26 degrees, and r of y equals 190 sine 26 degrees. And now we just plug into our calculator and solve. So r of x is 170 meters. The r of y is 83 meters. And again, you can manipulate these trigonometric functions in a variety of different ways in order to solve for a variety of different variables utilizing these types of problems. Now, vectors can be added by placing them from head to tail, and resultant vectors are made by adding or subtracting two or more individual vectors. So we need to kind of think about when we have multiple vectors that are together, essentially what we need to know is what is the total displacement on the x-axis versus the total displacement on the y-axis. And then we can use the Pythagorean Theorem to plug in and solve. Remember that vectors involve displacement, so it is possible to have negative numbers. You'll see what I mean when we look at the next problem. So let's look at the following problem and determine the total displacement. Now, in this instance, we're going to be adding and subtracting vectors here because our displacement is not a straight line like it was previously. We've got two separate vectors that we're going to have to take a look at here. But the key thing to remember is that we can add them together. So if I know the total displacement of the x-axis, and I know the total displacement of the y-axis, I can essentially turn this into one triangle in order to be able to solve using Pythagorean Theorem. So the displacement of the x-axis, remember the x-axis runs from left to right, we have 8 and 26. So that gives us a total on the x-axis of 34. On our y-axis, we have a displacement of 13 and 7. When we add those up, we get a total displacement of 20. Now I can think of this as one individual triangle. I have 34 here and 20 here. So now I can solve for this using Pythagorean Theorem, right? Because we know that c squared is equal to a squared plus b squared. So if I isolate the variable c, we're going to get 34 squared plus 20 squared, and we're going to take the square root of whatever that answer is in order to solve for our total displacement. And when we plug that in, we get a c value is 39.5 meters. Okay. So just keep in mind you're able to add those vectors in and be able to solve for, again, whatever you're looking at. Let's move on. Now I'm not going to show you an example of this. Now I'm not going to show you a specific example of this, but a negative of a vector can be represented of the arrow of the same length as the original vector but pointing in the opposite direction. So you'd be able to subtract vectors as well if the particular vector movement was going in the opposite direction on either the x or the y axis. You would just subtract rather than add like we did in the previous problem. So again, it's a pretty straightforward video. We just need to make sure that we keep in mind the trigonometric functions that we need in order to be able to solve for a variety of different variables here. And you'll see a lot of this in the practice work that I'm going to ask you to do a little bit later on. Make sure you can understand that horizontal and vertical motions are independent of one another and can be added separately. And explain the concept of vectors and how they relate to trigonometric functions. Also be able to add and subtract basic vectors. Again, thank you guys for your time. I really appreciate it. Make sure you drop a like on the video, and we will talk to you guys next time. Have a great day, everybody. Bye-bye.